Alright, so this video is going to go over this recursion practice number 1, and this would be just like a typical warm-up that we would do in class when the bell rings. It's only 5 questions long. I have the answers included in here. This will just be me demonstrating everything, and I'm going to make a bit more room because I've got this electronic pencil that usually doesn't it just doesn't write too well. So anyway, let's start going through this. We've got a recursion problem where we've got a print num method where 52 is passed in. So 52 is n, so I'll write down n. Then we've got this print number method, which is n minus 1, and then we have our s.o.p n. So this is how you'd want to solve this on your paper. So n is 52. So we've got print number, which would be 51 gets passed in because 52 minus 1 is 51. And so we don't print this because, remember, it just calls itself. So then we get 51, then we get print number, I'll call that 50, and then so on and so forth. It would do this until n was equal to, well, 1 is still greater than n, or 1 is still greater than 0 right there. So I go print number, and then it becomes 0, and then we'd have 0 print. 0 is is greater than or equal to, so it actually wouldn't do anything there because it would be done. So then we got to pop back up our stack. So this is where we'd have 0, then 0, 1, and then all the way back up to where we have 0, 1, dot 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 dot, 51, and then we've got 0, 1, 51, 52. So this is what your final print would end up looking like. Now, I skipped a bunch of these because I wasn't going to go through this 50 times, and neither should you, but that's kind of how that works, okay? That's how I would write that out. So if I ask you to write out something like that on a test, you would do it something like this, okay? And again, the answers, I guess, are important here, but in my mind, what's much more important is the process, because, who knows what they're going to throw at you on this AP test at the end of the year, and so you need to know how to solve for all of them, okay? So next up, we got a what value is returned when mystery sum 5 is called? So we've got our n value, n, and then we've got what? We've got, this is 5. Is n equal to 5? So return, nope. So then we've got return this 3 plus mystery sum of n minus 1. And, then we're going to, pop back up the stack. I'll just say pop up stack. Okay, so then we got n is 5, so 3 plus, I don't want to write out mystery sum. I'm going to just say ms, and then 5 minus 1 gives us 4. Okay, 4 is not equal to 0, so we got 3 plus ms 4 minus 1. becomes 3. Then we got 3 plus ms 3 minus 1, which is 2. So then we got 3 plus ms 2 minus 1, which is 1. 3 plus ms 1 minus 1. That gives me my 0. So then is 0 equal to 0? Yes, so it returns 0. So 0 is right there. So then what we do is this, the 0 starts popping back up the stack, kind of like our, again, like our Russian doll with multiple layers. So this right here becomes 3 plus 0, and that is 3. And then this 3 right here gets plugged into this one right here. So then we've got 3 plus 3, and that equals 6. And then 6 gets plugged into here. So then we have 3 plus 6 is 9, and 9 gets plugged into this one. So then we've got, I feel like I missed one somewhere. 0, 0, this is 3. What did I do here? Did I screw something up? And no, I didn't screw anything up. It just kind of, something looked weird to me. So anyway, we've got 3 plus 9 is 12. And then I plug this back into this last layer of our Russian doll, and we get 3 plus 12. So final answer is 15. Okay. So again, the process was what matters. So you go through here and you just plug through the code, you know. It isn't equal to 0 until down here, but then you got to run all these, and so make sure you write them all out and then pop back up the stack, okay? So that's where that is. So, all right, let's do the next one. Okay, so we got mystery sum 5. So that's an A. A becomes 5. And then what do we got? Is A equal to 1? If it is, return 10, else return this 10 plus, again, I'm just going to call it MS, I'll call it MS2, A minus 1. And then we've got our popping up stack, pop-up stack. Okay. So we've got 5 being passed in, that's A. Is 5 equal to 1? No. So then we do 10 plus MS2, 5 minus 1, which is 4. So 10 plus MS2 is 4 minus 1, which is 3. Okay, 10 plus MS2 is 3 minus 1, which is 2. Again, A, none of these with A is not equal to 0, so we just keep doing this. MS2, we got 2 minus 1. Now that is 1, and 1 returns 10. Okay, so we've got 10 right here. All right, and so we start popping back up this stack where we have 10 plus, and again, this is 10 right here, so that's 20. Then we get 10 plus 20, which again, I don't know if I need to write the lines up, but that's where that comes from. That's 30. That goes right here. So 10 plus 30 is 40. 40 gets backed up right there. So we got 10 plus 40 is 50. Okay. All right. So again, the process is what matters. So make sure you're doing that properly. All right. So that's 3. All right. All right, this one's a little bit more difficult, at least I think. So we've got an X, and then what do we got? We got this S.O.P, where it's doing X modulus 10. Okay. And we got this if statement that checks to see if X divided by 10 is not equal to 0. And if it is true, then we do what? Mystery, I'm just going to call it M, X divided by 10. Okay. And then we still have to do this popping up stack, pop up stack. All right, so this one's definitely more difficult because look at it, it has a print there and a print there. Okay, so X is 4, 3, 2, 1. So we print 4, 3, 2, 1 modulus 10, and that is, how many times does 10 go into 4,321? It goes in 432 times with a remainder of 1. So 1 prints right here. The first time through, 1 prints. Okay. Then we get into here is 4,321 divided by 10 not equal to 0. That is true because remember it would be, well, I don't know what it would be, but it wouldn't be 0, okay? Because 10 doesn't go into this evenly. So then we've got, and this is written out bad. Let me write that out again so it looks a little bit better and more clear. Okay, so then what do? We do 4. We do basically, let's do this. We call the mystery method, and we do 4,321 divided by 10, and we pass that in there. Okay, so this right here is 432. Okay, if I divide those out, it's going to give me a decimal place, but they're ints, so it gets chopped off. So then I'm back up in here, and then I come back down, and I've got 432 modulus 10. Then how many times does 10 go into 432? It goes in 43 times, which would give us what? 430 with a remainder of 2. So it prints 2 then. So, you know, and I might write this below as well, but this is what we have with printing so far. It prints 1, then 2. And then mystery gets called again, and we pass in 432 divided by 10, which gives us 43. 43 modulus 10 gives us, it goes in, what, 4 times with a remainder of 3. So it prints 3 now. And then M calls 43 divided by 10. 43 divided by 10 is what, 4? 4 modulus 10 is the rule, if the left side's less than the right side, then we return the left side, so it's 4, so it prints 4. And then M4 divided by 10, these are ints, it gives us 0.4. That would be what it is in real life, but 4 divided by 10.4 sorry, 0.4, the 0.4 gets chopped off, so it's 0. So 0 gets returned here. If 0 divided by 10 is not equal to 0, 0 divided by 10 is equal to 0, so we're done with this, and now we got to start popping back up the stack. Okay? So in order to do that, we basically have what we had here, okay? So we had 4, this is 4 right here. So 4 modulus 10 is 4. So that's what prints, okay? That's right here. That's what prints. So 4 prints. And then right here, 43 modulus 10, that gives us our 3, so 3 prints. Then right here, 432 modulus 10, that gives us our 2, so 2 prints. And then 4321 modulus 10 gives us 1, so 1 prints, okay? So it does, because it does this one first before any calls to mystery, it does, 1, 2, 3, 4, but then when we pop back up the stack, we still have to do, what's the value of x at this spot? Well, it was 4. What's the value of x at this spot? It was 43. At this spot, 432. At this spot, 4,321. And when we pop back up there, it would print, 4, 3, 2, and then 1. And so that's where this second piece comes from. If you have 2 of these, you're going to have, one before and one after. This is just a general rule. The one before will print, one way, and then the one after will likely print backwards, okay? And so we're going to get more practice with these ones because this type is harder than the first 3 that you've done here. But this is how you would do something like this. And you'll definitely have something like this on the test and likely on the AP exam. Okay, so that's 4. And last one for this one. Just start on the next page. Okay, what is returned as a result? Mystery 7. Should be pretty easy. So we've got n right here. N is 7. Then we got what? 2 times, I'm just going to call it m, n minus 1. And then, popping up stack, pop up stack. Okay. So you got 2 times m. We got 7 minus 1. This gives us 6. Because remember, we got to make sure we only get out of this if it's equal to 1. And when it does, we return 1. So 2 times m, 6 minus 1, which is 5. 2 times m, 5 minus 1 is 4. 2 times m, 4 minus 1 is 3. 2 times m, 3 minus 1 is 2. 2 times m, 2 minus 1 is 1. 2 times m, 1 minus 1. And I'm running out of space. As you can see, this is now 0. 0 returns 1 right here. So we've got, what do we got? We got 1 right here. And this 1 gets thrown into this. So we got 2 times 1 is 2. And that gets thrown into there. Need to give myself a little bit more space. Maybe I'll go underneath 2. It goes right there. So then we got what? 2 times 2, which is 4. 4 gets put into here. So you got 2 times 4 is 8. 8 gets thrown into here, so you got 2 times 8 is 16. 16 gets thrown in there. 2 times 16 is 32. 32 gets plugged into there. 2 times 32 is 64. 64 gets thrown in there. 2 times 64 is 128. Okay, so final answer 128. So make sure you do these on your own and get them right. Okay, use these videos to teach you and to check your work, but not as a crutch. Okay, so this video